The question stands as a hot air balloon is moving up with an acceleration, constant acceleration of 2 meters per second square. Initially the balloon was at rest and initially a stone is dropped from the balloon. At t is equal to 1 second, another stone is dropped from the balloon and we need to find out the distance between the two stones at t is equal to 5 seconds. So let us consider the above direction as positive and the below direction as negative. For stone A, initial velocity was 0, acceleration is equal to minus g, time is equal to 5 seconds. So the displacement of the particle is ut plus half at square, s is equal to half minus g 25, that is equal to minus 250 by 2, that is equal to minus 125 meters. For stone B, now stone B is at an important juncture. At t is equal to 1 second, the hot air balloon also has some velocity. So the initial velocity of the stone B is not 0 at t is equal to 1 second. The initial velocity of the stone B is the velocity of the hot air balloon after 1 second. So we need to find out the velocity of the hot air balloon after 1 second to find out the initial velocity of the stone B, because when the stone B is dropped, it takes along with it the velocity of the hot air balloon which it already had at t is equal to 1 second. So for the hot air balloon, moving with constant acceleration in the upwards direction, initial velocity was 0, at t is equal to 1 second, acceleration is equal to 2 meters per second square. So the final velocity is equal to u plus at, that is equal to 2 meters per second. So the initial velocity for stone B comes out to be 2 meters per second in the upwards direction. That is why I have written a positive sign plus 2 meters per second. Acceleration comes out to be minus g because it is free in the air. The acceleration of the hot air balloon is not imparted to the stone B, whereas the velocity of the hot air balloon is imparted to the stone B. So the acceleration of the particle is minus g. Now time left with it for covering any displacement is 4 seconds, because we need to take 5 seconds from the initial time. So the displacement is equal to ut plus half at square, that is displacement is equal to 8 minus 5 into 16. So the displacement comes out to be 80 minus 72 meters. So the displacement of the first stone is minus 125 meters, whereas the displacement of the second stone is 72 meters. So the distance between the two stones comes out to be 125 minus 72 meters. That is equal to 53 meters. So the final answer for the distance between the two stones after t is equal to 5 seconds is 53 meters.